see it on Zoom. I'm just checking. Can't see it on YouTube yet.
I'm still waiting for YouTube. And here we are live.
On Zoom. I'm just checking. Can't see it on YouTube yet.
Okay, thank you very much for everyone waiting. There was a slight mistake with a time zone. It happens when our speaker is over the pond on the other side. Apologies to everyone that was waiting. These things, the time zone, sometimes just happen. But I'm, I would say, grateful that he actually was quick to respond to my message and to jump to the call, to the meeting. So a little bit, so this meeting is in conjunction with our two sister chapters, let's call them this way. We have Dorset, which is led by Mark Davison. He might be somewhere on the YouTube. Suffolk, Mark Davison, Alexios, Nigel Kay, and Mike Warner. And then we have Suffolk, where we have David, which is with us, Martin Ross, and Wojciech. And the Bristol chapter, myself and Craig, which is helping in the background with all kinds of things that needs to be maintained in order to ensure that everything is running smooth. A little bit about the OASP. The mission of the OASP is a nonprofit organization, which is community-led. We have lots of chapters around the world. That number is outdated. I'll have to change it. The mission of the organization is to promote the security of the software, the entire software that powers the world. And it is a open worldwide community, free for everyone to participate and to be involved. All the events, apart from the conferences, are free to join. So for example, like this OASP chapter meeting. But there are some events like the conferences and training events which are paid. However, there are two tiers of payments, and one of them is for OASP members, the other one is for non-OASP members. So if you want to be an OASP member, then you can actually join the membership. There is an individual fee of $50 for a 12-month period for individuals and a $20 for students. Also, one of our sponsors, like the Bristol chapter sponsors, is the Just Eat. Just Eat helped us a lot, especially before the pandemic, with hosting our in-person meetings. So it's a great partner of ours, and they have some vacancies in their AppSec team if you are interested. So they have a technology manager into the AppSec team, a training specialist for those that want to evangelize, app security training, and an AppSec engineer. Being a global company, the roles are available in London, Bristol, Amsterdam, Berlin, and there is a contact number for you if you are interested into any of these positions. Upcoming events. The next one would be, like the bigger one, is a virtual event, a virtual AppSec conference where in June, where there are two types of fees for the OASP members. The fee is $400, and for the non-OASP members is $620. So if we go back to the membership, you can see that if you pay $50 to become a member, you can actually save about $200 on the next conference. Other events are April webinars, and every month has been a series of webinars. The next one is in April between 12th and 12th and the 13th of April. And there are various sessions as part of that webinar, and one of the sessions will be held by Jim Manico, which is about developers training. And here you have the next one, which is in April. Then after that one, you have the July webinar and then an October webinar. The next event would be on SOFAC, which is on the best practices of securely working security on AWS, and again by our sister chapter SOFAC about all passwords. And now I'm going to pass to Dave to say more about what they are preparing in terms of next talks as part of their chapter. So Dave, from SOFAC team, please go ahead.
Thanks, Katie. Yeah, so we're trying to have at least one event every month, which is basically a speaker. So it's going to be 12 a year. As you said, the next one is going to be on AWS. We've also got a couple in the pipeline around machine learning and various other security topics. We're also trying to do a workshop every month. We did G-Shop last month, and we're doing all about, actually it was this month, wasn't it? No, I keep forgetting what month I'm in. Last one was the G-Shop one, and we're going to do all about passwords next. And we've got a few more lined up, possibly some live ethical hacking. So if you check our meetup page, there'll be more information there. Okay,
yeah.
Thanks.
Thanks very much, Dave. And yes, I put the link onto the slide of the next event, but then if you actually go into the SOFAC chapter on the meetup, this is where they actually schedule and put everything in place, and all of those would already be. So that's the first place where you can actually see what else is scheduled in the future as part of the OWASP SOFAC chapter. And now our speaker, which is Dr. Baljeet Malhotra, who will talk about API security and legal risk management. So thanks very much, Baljeet, for joining our meeting at very short notice. You can start sharing your screen, if that's okay.
Thank you so much. First of all, my sincere apologies for this time messed up. This has never happened. I should say maybe once it happened 2 years ago, but usually we are pretty good in mapping out different time zones. I am based in Vancouver in Canada. Nicole, my colleague, she's also based here. So I think we messed up on the PST time zone. So it was supposed to be 10:30 a.m., but she ended up blocking p.m. So once again, my sincere apologies. I hope that this session, although we are starting late, but it'll be worth your time. So I'll make sure that we spend this time together effectively. I was not able to put my turban on because of the short notice. But usually I look like this. So you missed to see my beautiful turban, but I hope this look is not bad either. So with that humor, please allow me to start my presentation. So great. So I want to start with a quick intro about myself, but if you can please let me know, Katie, how much time do we have since we lost some time? Do we still have like 30 minutes or so?
Yeah, you can have, 30, 45 minutes, yes, because we are still recording it, yes.
Okay, perfect. So I'll try to wrap this up within 30, 45 minutes, or 30, 25 minutes. So let me start with a quick journey that I can share with you about myself. I'm the founder and CEO of Tej Lab. Before starting Tej Lab, which is a company focused on API management, I was the VP of research at Black Duck Software. I started build their R&D team here in Canada. If you know open source, if you have looked into open source ecosystem, we were the market leaders for providing some of the open source risk management. Before that, I was with SAP as a research director, again, looking at open source risk management across SAP products and services. Before that, I was with academia, did my PhD at the University of Alberta, did my postdoc at National University of Singapore, and started my career as a software engineer. So, and quite frankly, I'm not a security expert like many of you guys are at OWASP chapters. My training is in applying data science, data management tools for large-scale data problems. For example, mining data related to open source or APIs for risk management. So that's a bit of my journey in the last 10 years or so. So today's topic is about managing APIs. But before I get into the risk management aspects of APIs, I want to talk about how the API ecosystems are evolving at a global scale, as well as within enterprises. So here is a picture that shows how an API or a collection of APIs could connect your enterprise systems, your social media channels, your ERPs, and whatnot. This is a snapshot of a API footprint of an organization, where you can see that each dot represents different APIs or vendors from which the APIs are being consumed. So the interesting aspect about this API is we are not only tracking these APIs at a global scale, but if you have a smaller footprint of your APIs across your enterprise applications, you will see a similar kind of footprint as well, of course, with less number of dots. But there is a huge impact on data sovereignty. So it's not about just managing APIs, but think of APIs as tools that are always transacting data for you. So API provider could be a vendor which is based in the UK or in the US or in Canada, but their services could be hosted in India, China, or anywhere else. So from a data sovereignty perspective, from a data governance perspective, you can see the impact of these technologies. So why we care about APIs? If you look at the blue curve, that shows the growth of websites. Back in early 90s, a lot of innovations came along the growth of APIs, and they grew from 100,000 web pages to millions of, billions of websites and whatnot. We are seeing same transformation for APIs as well. You see, great companies born along this journey, but we have started to look as a company how this will impact the security aspects of organization, their legal posture from a compliance perspective, and that's why this interests us. There are some interesting numbers here. If you look at my right-hand side of the slide, 83% of the internet traffic today is through APIs. This is a mind-boggling number. In theory, this could also mean, your organization has that many entry doors, coming from the API usages. And, a lot of research organizations, they have estimated many of the attacks would come through, for the web applications would come through the API usage. And that tells us why. So we as a company, we are tracking hundreds and thousands of APIs. We have a rich source of data that allows us to do the data mining and surface the informations that I'm going to share with you. So this allows us to look across different industries, what kind of APIs are being built, what these APIs do, what data is being transacted, what's their security posture, are their authentications in good shape or whatnot. So this knowledge base that we have created actually allows us to do some of the interesting insights that we have gained that I'll share with you in this presentation. So before I go into different API risk management related issues, let me share with you a couple of examples that we observed. This is an example of um, API leaking data that we had captured. So this is a real example. This is not a cooked up example. So we found this API leaking credit card information of US taxpayers, their credit card information, email addresses, not only that, but the security code of the credit cards. So which essentially allows us to do the transaction, not just compromising on the privacy, but also the financial loss. So, and we believe that this is just the tip of the iceberg. There are several other cases we have found, but of course, not every API is transacting credit card information. But we have seen cases where developers' email addresses. In one particular case, we were able to find a community where through APIs we could scrape hundreds and thousands of developers personal information, their emails and whatnot. So, and that's again through a compromised API. So the point I'm trying to make here is we see more and more these cases, and you will continue to see these cases rising within the enterprise landscape. Here is another interesting piece of research that my team did. We looked at last 10 years of National Vulnerability Database. As you know, National Vulnerability Database managed by NIST contains a lot of vulnerabilities that got reported about operating systems, applications, a lot of open source related vulnerabilities as well. We took that data and we mapped the vulnerabilities that we could relate to API specific problems. And the problems that you see on the left-hand side, broken authentication, authorization, some of the other problems that are listed there, are some of the top problems that we could see, which is represented by the frequency in the middle column here. Now, this is very interesting. Thanks to OWASP organization or the community, you guys have given OWASP top 10 secure API-specific security recommendations. And this independent investigation validates that what the top 10 recommendations are actually being supported by these empirical results. If you have not looked into, then in the top 5 OWASP API-specific recommendations, in the top 5, authentication, broken authentication, and broken authorization are the top 5 in the top 5 problems. In our case, we identified these to be top 2 problems. Now, this actually gives us insight from 2 perspectives. The first thing is the community work that is being happening is actually on the right track as we see the real examples. The other thing is we can actually see on hundreds and thousands of API investigations we did, we could actually see what kind of authentication and authorization problems we see in these APIs that we investigated. And I'm not going to go into, how the authentication is compromised, how authorization is compromised. I mean, you guys are the experts. My focus for the rest of the presentation will stay on what kind of API ecosystems we see within enterprises and how we can take this authentication, authorization, or other API security specific problems and map them to different risk related issues. For example, financial risk or legal risk or operational risk. So we will traverse that journey. But Katie, just as a quick feedback from you, how I'm going? Am I going too fast in the spirit of since we lost time, or you think I'm going fine with my speed? Any feedback?
It's fine. Yes, it's fine.
Okay, thank you, Katie.
Don't rush it. Take your time.
Okay, thank you. So now from that 30,000 global view, where we have seen some trends from APIs that are shaping up, global digital economy, I want you to take you to the enterprise ecosystem. And in particular, on this slide, what I'm listing here is buckets of different APIs you could see. And this is classification is something that will help you understand, what kind of risk we are looking into. The first bucket of APIs you may see within the enterprise ecosystem is external APIs. APIs that you may have gotten from your customers and partners, may have integrated with your own products and services. But external APIs could also be those APIs that you are exposing to your customers and partners. You may already have an API marketplace. If you go to the middle, then you have internal APIs. These APIs could be APIs that you have actually built for your internal business units. Maybe these APIs, again, are from your partners, but they are not publicly available, but they are made special available to you for various product and services integrations. Now, the very nature of these external, internal APIs, some of these could be public, some of these could be private. That itself could be very, very ambiguous. The nomenclature itself could be very ambiguous. On top of that, your organization may actually be dealing with certain APIs that you do not even know. Now, how is that possible? So let me give you some examples here. In my previous organization, where we had looked across different industries to understand what's the open source consumption, and we had learned that 80 to 90% of the applications are built using open source. So, I mean, de facto, open source has become de facto industry standard when it comes to software integrations. Now, what is happening, and our research shows that when you use certain libraries, it's very likely that there could be certain API integrations in those libraries that you have downloaded from GitHub or other publicly available resources. The reason could be you want to integrate a certain technical functionality or business functionality, but these open source communities are already providing certain web API integrations, for their own, purposes, collecting some metrics, providing some social integration sign-ons, and different reasons could be there. Now, when you use those libraries without actually realizing those APIs are there, that could pose a significant risk to your organization. And it makes sense. If you do not even know your APIs, then how can you assess their security posture? How can you assess, what these APIs are doing, and what could be the licensing risk? What could be the security risk? So from those perspectives, I think it's very clear to us as a community, we must ensure, the API security posture must be robust. Their authentication, authorization, although is a business logic that you write somewhere, but oftentimes there could be libraries that enable that. And we have seen multiple cases where authorization is compromised. Just because you have authentication does not necessarily give you the privilege to access all the resources. And we see the business logic being broken. Sometimes you being a normal user get access to admin resources. And a lot of resources get access through the different API integrations. You talk about AWS. You talk about other cloud solutions. Even simple cloud applications may have those kind of integrations. So we understand what those security implications could be. But the licensing, the financial risks, operational risks are not so much clear. They need some sort of education there. If you look at the open source model, then the risks are very clear, because you may have a GPL, you may have a wider license, you use the library, and of course your licensing colleagues or your legal colleagues are worried about, do we have the rights to use this? Free does not necessarily mean that you don't have obligations. APIs are very much in the same bucket, but they pose even more greater risks. The fact is, the moment you integrate an API, that API, when vendor is providing, they already have terms of services that could rapidly change. There is no fixed term, there is no fixed license. And the fact is, compared to the open source, unless until somebody has access to your source code, they never know which library is being used. And as more and more software moves into the cloud, companies are not shipping their software, right? So lot of applications you just log in through cloud systems. But with APIs, those integration happens. The moment you make certain calls, if this was a free API, a lot of APIs are being built with open, with open technologies. A lot of innovation is happening in the open space. The moment you integrate those APIs that are publicly available for free, the vendor automatically knows you have used their API. It's unlike open source usage. So the risk from a legal perspective is much greater because they know. Perhaps they have told in the terms of services, oh, first 100,000 calls are free. First 50,000 calls are free, or you can use this API with this particular purpose only. But the moment your solution scales to larger markets or usage, you suddenly have exposed yourself from a legal standpoint of view to certain obligations. If you look at financial risk, it makes complete sense when you have APIs that are transacting dollar value. Let's talk about credit card API integration. If that API shuts down or if it is compromised, you can see the financial impact immediately. But that is not to say that other APIs may not have financial impact. Talk about, let's say, a Twitter API or an API that is providing you social media feeds. If each of those data elements has a dollar value, if that's what your business model is, a service of denial attack or not having a rate limit against your API usage, which brought down your service, could have a financial impact on you because that may directly relate to your services that are generating revenue. The operational risk is, again, not apparently clear, but let me share a real story there. I was part of a team that was responsible for conducting M&A due diligence from a technology point of view. So we would go simply use technology like Black Duck or others, static analysis tools to understand, to do the software composition analysis, understand different libraries, look at different licenses. We would work with our legal colleagues and, procurement team to understand what open source bill of materials are there and, assess the due diligence. In one particular case, we had bought this company. Everything went well, the transaction took place, we did the technical due diligence, everything went in the right direction. But 6 months down the road, this asset that we had bought and integrated within our larger enterprise ecosystem started to choke. We had no idea what was happening, but eventually the long story short is we narrowed down the problem to one specific API that was basically basically blocking the entire workflow. So this API was going into the loop, and since it was not fetching the data that it needed to fetch the way it was supposed to, and the rest of the workflow was broken. So the moral of the story is there was no immediate legal impact, there was no immediate security impact, but you can imagine, the credibility we lost. We had to figure that out. It had a downtime. A lot of dollar was wasted on the due diligence again. So it was not a good experience. Similarly, from a regulatory point of view, let's talk about. I mean, you guys are in Europe, so where GDPR took place, and once you have been asked to disclose certain third parties that might be dealing with personal information, it does not really matter who the vendor is, where the products are integrated from. You have certain obligations to disclose these third party integrations. And in one such case, we failed to recognize certain APIs. The vendors were in a specific country, but actually their APIs were hosted in a different geography. So even a single sign-on API, which could be storing email address or the first name, last name, millions of such data was being stored somewhere else. So since we failed to disclose that information, that led to certain obstacles to us. Nothing against security, nothing against to do with security or legal risk, but again, it slowed down the process. It cost us reputation. It cost us problems with our auditors and other issues related to regulations. So how do we learn these lessons and look for certain models that can help us manage these risks? And by the way, just to make sure that I'm not trying to claim here this is the only way for you to classify your API risks. You know very much risk is all about managing. It's never the day when you say, I have a zero risk in my organization because I have the best tools, I have the best process in place, I have the best people training and all that. That never happens. So API risk management is very much similar to that. Once you have those problems, you must identify. And what I proposed here is one way to classify those risks. Unfortunately, we do not have something like CVSS score that we have for vulnerability management. I wish there was. We are very actively as a research, we are looking into this problem, including with our stakeholders, and trying to identify if we can see some sort of analytical way to prioritize our API risks and see how these could be useful. And this becomes very, very important. Reason being, if we had only a handful of APIs, 10, 20 APIs, we can still manage this manually. But we are talking about tens or hundreds or perhaps hundreds of thousands within single organizations moving forward. As applications become more and more web-based applications, where IoT takes off in a big way, many of these services will become available through those APIs, and the integrations will be at massive scale. So, and hence prioritization will play a key role. How you do it, it is very subjective to your organization, as in many of the examples I explained. But again, looking at API security problems and then mapping them to risks, different risks that I listed here, is going to be very, very important exercise. So now let's look at some of the models that we can use. And once again, I take inspiration from open source world again. If you look at, some of you may already be practicing this as part of your daily routine. You may be conducting pen test, maybe doing a software composition analysis, and a few other aspects as part of your process. So if you look at the list that I have given here, if you are doing software composition analysis, the first thing you do is, software supply chain. What are those components? What type these components are? How old they are? Which communities are managing these components? What are the open or publicly available vulnerabilities? So whatever you can track to actually monitor the health of these libraries would actually help you. In a similar way, we need to do this for APIs as well. And in particular, you must track your APIs. You must know your inventory. If you ask any CISO or CIO or CTO, do you know all your APIs across your products and services? And quite frankly, you will really find an answer. In most of the honest answers, you will say, oh, I really don't know. I need to find out. A lot of organizations are in the same boat, simply because, because of the open source usage, because of the M&A transactions, because of the fact that APIs are so publicly easily available that developers, through their creative designs, can integrate it so easily. And of course, there could be documentation challenges to understand those APIs, how to integrate. But again, finding your inventory is very, very important piece. You must know what these APIs do. If your lawyer is involved in due diligence, they want to know what data is being transacted. If it's a single, even if it's a single sign through a social media API, what data will be stored by this particular vendor? Are they storing our emails? Are they storing our IP addresses? What are the licensing risks? And one of the key points I mentioned here is, unlike open source or licenses that are usually governing our software libraries, In this APIs, rarely there is a license, or you could have a license, but on top of that, you may have developer agreements, you may have API terms of services. And because of the very dynamic nature of those APIs, because they're always transacting data, there are no fixed terms. If you go visit Twitter website, if you go visit your vendor's website, you may be having a commercial agreement in place, but their terms of services could change on you at any point in time. And the obligation is on to you as a consumer to be compliant to those terms of services. So you need to track all of that. And once you have that, then you have some way to start to first of all, quantify those risks that I talked about and manage those risks moving forward. Once again, Katie, I'm looking at my watch. Looks like we still have 10, 15 minutes.
Yes,
we are good? Okay, great.
Yeah.
So let me sum up what I have presented so far. So all the problems I described, it almost feels like we actually need a Swiss knife, just like, there is no single model, there is no single practice, there is no single tool actually can solve all these problems I talked about. If you have a gateway solution, maybe that's good for access control. Maybe they're tracking your API usage, rate limits, and all that. But what about the licensing terms of, or the terms of services? What about some of the other aspects I talked about? If you have a design tool, that's not going to tell you who's using your APIs. So what I'm trying to say here is the problem within the API ecosystems are so complex. No single tool or no single process can actually solve all these problems. We almost need like a specialized tools, like a Swiss knife to handle like a bottle opener or a corkscrew, or different kinds of tools to actually solve all those problems. And that's why, the inspiration for a Swiss knife title. So let's look at what is that Swiss knife, at least that can help us to start with. And we don't need to reinvent the wheel, because there are certain models that are already enterprises are adopting. And one of those models is zero trust. Zero trust, by the way, is not a specific tool or technology or a process. It's a methodology which you can adopt for larger cybersecurity program. But let me quickly revisit some of the principles, or actually not some, but to be very precise, 7 core principles of this zero trust model. The very first principle of this model is you must treat all your data sources and software services to be a resource. And the second principle is you must access these resources through secure channels. You should not have a reason to, let's say, have a service which is outside your DMZ, if that's what your policy was. And the third principle is all those resources that are being accessed through secure channels must be accessed in a sessional way. So there should be no situation that somebody has access to some resource infinitely time period. I mean, in theory, you could have somebody who has access to all the resources, but again, all these accesses must be sessional, session-based. And OAuth, API keys, all these different frameworks are, you can imagine, are ways to actually provide that kind of session. Of course, I'm not saying that the token should expire in a day or a month or whatnot, but again, you get the point. The policies that give you access to those resources must be dynamic as well. And you will see a lot of organizations have adopted this aspect in their lot of services. For example, email, when you change your location, suddenly you get a notification that you are trying to access your email. Is that you? So you see that they check those policies in time and space. And the fifth core principle is you must monitor the integrity and security of your resources at all times. And that is to say, you may have certain models that are already part of your firewall or different tools that you have put in place, which are monitoring who's accessing your resources. So you must constantly evaluate those. Authentication and authorization is key piece, and as we will see for the APIs, this is one of the top recommendations within the top API recommendations, API specific recommendations. So authentication and authorization is such an important area, and I'm so glad this community has looked into this area in a much deeper way. So authentication authorization is much important as a pillar for this model. So that must be enforced across your resources. Last but not the least of this model is, regardless of monitoring mechanism in place, regardless of dynamic policies in place, regardless of sessional approaches to access those resources, you must collect additional pieces of information on your resources. In the context of APIs, I will give you more concrete example, but that is to say, all these dimensions are not good enough for you to avoid future threats, right? But of course, we live in a GDPR world where we must respect privacy concerns. But again, you must constantly, regularly collect additional pieces of information to evolve your security risk posture. Now, let me quickly map those principles to API risk management. So very clearly, as you can imagine, treat your APIs as resource, treat them as products. Rule number one. Rule number two, there is no reason for you to have a API that is built on HTTP protocol. And more importantly, you cannot just say that, oh, this is just internal API, this is outside my DMZ zone. Nobody knows this. The other piece that we have already talked about is, used frameworks that control your sessions. It may not be possible for you to have a sessional approach across all your different APIs. Let's talk about OAuth. Now, it may not be possible for you for certain business transacting APIs. The fact that APIs are designed and built for seamless integrations, having too restrictive approach from a sessional approach may actually defeat the purpose, right? So you really want to see what these APIs do, what's your business model, and what these APIs are supposed to do once they are designed and built. So there is no single solution I can recommend here. So you must evaluate what these APIs do, what's my business model, and how these APIs access or sessional approaches must be controlled. Policies, again, I don't see any reason why the policies cannot be dynamic when it comes to API usage. The monitoring, again, we must constantly evaluate the security posture of these APIs. Perhaps we could simply run a OWASP top 10 test against our APIs and see how we perform on a scale of 1 to 10 for all these API specific recommendations, either is broken authentication or authorization or injection problems, or even in some cases, cross-site scripting that can be injected through some of the API parameters. And the last two, as I mentioned, of course, you guys understand authentication and authorization is so important for APIs risk management purposes. Last but not the least, how can we collect additional pieces of information? Let me give you actually, this is a very important area of research as it evolves. Now, APIs very much are transacting data. There is an input, there is an output, okay? Even though you may have policies, you may have gateways, you may have firewalls to access control your API usage, which user is using which APIs, how many, you may have rate limits and whatnot, but still that may not be enough for you to manage risk. And one of the greatest risks is your intellectual property could be threatened by the way the APIs may be exposed. Maybe you have a collection of APIs. A correlation across those different API uses, the data that you're exposing may actually lead to certain IP risks. Now, it may not be possible for you to simply authenticate and authorize and just say, okay, I'm not worried about the future cases. But we have seen cases where legitimate users, actually there's a case in which our client approached us saying that, Baljit, we believe that a lot of authenticated users, legitimate users who have registered on our API portals are actually abusing our APIs in a specific way. we have no way to do it. So how we can identify those behavioral aspects which will allow us to manage those risks. And one way to do is store the payloads or store the inputs that you can and mine those data over a period of time to see what kind of analysis or patterns are emerging from those data. Now, it may not be possible in all the situations. Your customers may not like you store their payloads, or if you are consuming somebody's APIs, the API provider may or may not allow you to store their inputs. So it really depends on your SLAs or terms of services, what additional pieces of information you can store. But again, in many cases, if you can anonymize this data, you still mine it to collect the behavioral aspects of usage of your APIs. And we are talking about hundreds and thousands of calls, millions of calls across your different usage user base, right? So mining that data becomes very, very important. So now let's put those models into practice now. Okay, so I'm going to define what kind of process we can put in place to manage these API risks. And the key aspect or the very first stepping stone here is find your APIs. Scan, discover, talk to your developers, talk to your product teams, talk to your engineering teams to find those APIs and consolidate where those APIs are. It may not happen in one day, it may not happen in perhaps in a month, but you have to start somewhere. So finding APIs is very, very important, and identifying those issues is going to be key. And it's not just that you do this one time. As I've stressed enough, APIs are very dynamic in nature, as you know. So constantly evolving and tracking these changes, evolving different risks that I identified is going to be a key to your success in managing these API risks. Alerting different stakeholders. It's not just a one stakeholder problem that there is a product team or there is an engineering team who has built APIs, they have integrated APIs, and we are done. Or even they have a security expert, we are done. There could be licensing team. There could be a team that is actually responsible for enterprise-wide licensing. And maybe they have purchased a certain APIs from vendor. Are these APIs being used across different teams? Is there a one license? Are there multiple licenses? Are different teams using different accounts and whatnot? So there are multiple stakeholders, and managing those risks across those multiple stakeholders is going to be very, very important. And recommendation, of course, is inherently as part of the process, because if you just keep identifying problems, that doesn't help anybody. So the recommendation could be as simple as why this API is, in this particular library. This is supposed to be internal, and guess what? You decided to make that software as open source, and you contributed back to the community. But there you go. Your internal API became exposed, and that's not good. So the recommendation could be, shut down this API or make this a private API, whatever the recommendation might be. Or recommendation could be as complex as, our authentications across these different APIs are not strong enough. Or this particular vendor, we thought this is based in the UK, but their services are hosted in the US. And we don't want our data to be stored outside this geography. So how do we move that? How do we work with the vendor? Because initially when you onboarded this API, maybe this was a vendor which was very small, very unique solution, a very key element or feature support for your product. But again, things evolve. Now suddenly you need to scale to millions of calls because suddenly your product is successful. But again, this API is a very integral part of that. So how do you manage those issues? So in summary, I was actually planning to show some hands-on scenarios with whatever I described, but we will not do this today. Maybe if you guys give us the opportunity again, we'll come back and do this workshop again, but in a more hands-on way. But for today, I'm sharing this link with you, and feel free to get access to this portal. This is a community portal. Accounts are free. They remain free forever, no charges at all. But again, this will give you some idea about some of the risks I talked about, some of the APIs you can see, how we identify risk and whatnot. There could be some tutorials available. But if you struggle to understand some of these use cases I talked about, feel free to reach out to me or to Katie. She'll be happy to connect us at a later date. So let me summarize what I talked about. And I should be done in the next 2 minutes. So we talked about how APIs are important and how they're massively evolving at a global scale. As I showed in one of the graphs, we are already tracking thousands of APIs as an API management company. But do you think they will stay to thousands? No. They're going to grow to millions, and who knows, to billions. Every IoT device, every AI solution, every data essentially has a potential data source has potential to become an API source. I was talking to this Norwegian company who provides cameras, security cameras. They are one of the top leaders in this space, and they're talking about not selling cameras, but just the service, and integrations happens through all those APIs. Who owns the data, and all those questions come in play. So governance to those APIs is going to be very, very important part of your your enterprise security and risk management. So if you're doing AppSec, if you're doing risk management, and if you're not factoring APIs, you are not doing a good job, very bluntly. So it starts with finding your APIs. It starts with knowing the vendors. It starts with finding what those APIs do and doing the legal assessment, security assessment, and whatnot. And in the later part, I talked about a particular model, Zero Trust, which can actually help us. We don't need to reinvent the wheel. There are certain really good aspects about this model that really linearly transform or can be mapped to API risk management, as I showed with the 7 key principles. Lastly, but not least, I shared a portal, community portal that we have built, which we have made it available to OWASP community, ISACA community, and other community members. We are giving this kind of talks. This is my contact information, and please feel free to reach out to us or ask Katie to connect to us. We'll be very happy to be part of this community. Once again, very honored that you guys invited us. And I'm sorry again for the time we messed up, but I hope this session was useful. Thank you again to you and to the rest of the OWASP chapter at Bristol. Thank you so much.
Thanks very much, Baljeet, for the talk. We have some questions in the YouTube channel. So one of them is, one of our members says that this is a very different way of looking at APIs. Do you see the emergence of new tools to help people to understand or catalog their API portfolios better?
Absolutely. And I think this is a very interesting question. You talked about new tools. We as a company, we were born just a few years ago simply because we didn't see the solutions that were existing could solve the problems that we were looking into. So absolutely. And the other aspect about categorization. So I think that's a great way to start to consolidate your APIs. Once you have categorization, this is my categorization could be any based, business unit based or industry based or product based. That doesn't really matter. But you must start consolidating your APIs with some sort of categories, and that's a really good beginning for you. So absolutely, yes. Thank you for the question.
Yeah, another one. So in one of your slides, you actually, it was shown that on the top most common reasons are the broken authorization and broken authentication. Do you have more details about these?
Yes, we do. Unfortunately, not in this slide. I couldn't include because of the time limits. But for the broken authorization, we saw cases like the nomenclature itself is a problem. For example, every resource has a URL, an API, you have admin/resource1, business unit 1, and all that. We found cases where by simply exploiting the nomenclature itself, for example, from the URL, changing the business unit 1 to business unit 2, we were able to access some of the resources. So just because I have access to business unit 1 API, I should not be accessing business unit 2 API, but that happens. And this is a very common problem. The other problem is mass assignment, which I see in the same case as well. IDs. Again, I see that as a problem authorization based simply because in your URL, you have an ID that you can iterate. And those IDs you can iterate from 1 to 1 million to get access to different users' data or customers' data and whatnot. First of all, don't use IDs that are guessable. Use UUIDs or something else that are not easily to do that. Even if the authorization framework was broken, simply because the IDs were not guessable, you could avoid that problem to begin with, right? But again, that is not to say that you have UIDs and not authorization. So in authentication, we see some cases where there is no authentication at all. We saw authentication with very weak API keys. We could actually guess those keys. We saw cases where tokens never expired, and few other cases as well. So yes, there is a wide range of problems. In one of our other OWASP presentations, we showed results from roughly around 1,000 APIs, what kind of authentication authorization problems we see. Maybe, Katie, in a future discussion, we can present those results with your chapter. But again, I hope that answers the question.
Yeah, thank you very much. I see that's all on my side. Dave, Craig, any questions from your side?
No, I'm quite happy with that. I suppose, I don't know if I missed it, but towards the beginning of the talk, you gave some numbers of how many vulnerabilities you'd found. Had those come from like automated scans, or had you actually sort of really investigated into it?
That's a really good question, Craig.
Mm-hmm.
And that's where we applied our expertise from natural language processing or other data science we can apply. There was no tool to identify programmatically, is this API that is reported in National Vulnerability Database specific to certain API? Because there is a description, there are other details. I mean, that's unstructured data. There is no way to identify that. So the short answer to your question is we had to apply and develop certain tools internally to mine those data. For example, we looked at, in that description, is there a talk about an API? Is there a description about an authentication or authorization or something like that? So we applied different ways to map those. There was no tool that could automatically map them for us.
Yeah, and it's so you're just sort of trying to get an indication of numbers, but because it's always tricky of, can you exploit it? Because if you're going to be doing something which sort of goes, all right, I'm about to delete all these records, you don't really want to be playing with that one because you might upset some people. And
that is true.
tools, yeah,
that is true.
And these were your clients, as in they were asking you to check their APIs, or were these open APIs open to anyone to scan, or a combination of both?
Yeah, so a lot of these APIs, the analysis that I showed was done just based on the data itself. Mm-hmm. We did not actually did the white box testing where we actually, invoke the API, pass some injections to see how it behaved, or looked at authentication or not. Although we have the capabilities to do it, but as you said rightly, we didn't want to piss people off. So we only did it to APIs when the vendor agreed that if you allow us to break your APIs, we can show you different ways by which we can break your API. And then we would show them a report and show them, look, this is how we did it. So just looking at, let's say, rate limit tests, we could simply generate thousands of calls and see whether API is responding back. One of the recommendations in OWASP top 10 is, rate limits, because that could, if there is no rate limit, it could lead to service of denial attack, right? Okay. So there was no fixed way or methodology to test and collect all this data. So we applied different ways, applied different technologies to come up with those results.
Brilliant, thank you. Okay, so do you want to take the next set of questions?
Yeah, there is another question. What form of testing would you recommend for catching these issues before the deployment?
So if you already have a good design tool, security always starts with design. There is no way you can build something and say, this is going to be good. So it starts with design, and there are a lot of open source tools or, freely available tools in the place. But once you do that, you can run a top 10 test and see, does this pass authentication authorization tests? What happens if I fuzz with these APIs? Does it respond the same way it is supposed to do? So it starts from design. And I think understanding what this API is supposed to do, is it an API that is going to be massively called as part of your business transaction? Or is this an API once in a while needs to be called by our partner? So you really need to look into the design from get-go, involve different stakeholders, understand, and then of course enforce different constraints from zero trust model that I talked about. And then once the API is built, design, then of course run some test cases, including white box test cases you can run and see whether you can break those APIs even though design was in place.
Excellent, thank you very much. Dave, do you have any questions on your side?
No, none for me. Thank you. That was very comprehensive.
Thanks a lot, Baljeet. Thank you very much for the very interesting session that you delivered today.
Thank you so much, Katie, Craig, Dave, and the rest of the OWASP chapter at Bristol. Very honored to be part of this
Suffolk,
community.
we have also Suffolk and the Dorset. Dave is from Dorset. Sorry, from Suffolk.
I see. Okay. Well, thank you, everyone. Thanks to the entire committee for inviting us. And we really look forward to seeing you guys in the future.
Okay, thanks.
Thank you. Bye-bye.